right, so this time we're looking at some radical equations. This just means that they have a square root or a cube root or some type of, index there, some type of radical. The thing with these is sometimes you'll have one solution, sometimes two, sometimes no solutions. You probably, until you really get the hang of this, you should probably check your answers. All right. So what you want to do is get the square root by itself somehow. All right, just on one side by itself, and then you're going to raise both sides of the equation to the second power. All right, in order to get rid of that square root. If it was a cubed root, you would raise it to the third power. Right. So the square root of all this squared just gives you 2x minus 3, and over here you get 16. Add 3 to both sides, you'll get 19. Divide both sides by 2, and you'll get 19 over 2. Now you do need to check your answers, all right? So let's plug 19 over 2 back in for x. So the square root of 2 times 19 over 2 minus 3, and hopefully we get 4, right? 2 times 19 over 2 is just 19. All right, the 2's cancel. Minus 3, you get 16, which does equal 4, all right? So because you plugged it back into the original and it actually gave you what the original had, it does work. It is a solution. Now over here, you should automatically know that this does not make sense, all right? You've got the square root of something and it equals a negative. Well, that's impossible. You can't have the square root of something giving you a negative. This is going to be no solutions. All right, we know that from the beginning. But if you wanted to, you could square both sides and see for yourself. But I don't have time, so moving on. All right, in this example, you've got square roots on both sides. It's not too bad. There are some coefficients out front. I would recommend dividing both sides by 2 before you get started here. All right, divide both sides by 2. You'll end up with 2 root x minus 4. And on this side, the 2's just cancel. So you get root 2x plus 3. Now if you square both sides, on the right side, you'll just get 2x plus 3. On the left side, you're going to get 4, because that's 2 squared. And then you're going to have the quantity x minus 4 being multiplied there. All right? So we need to expand this. That's 4x minus 16, 2x plus 3. We need to get all of our variables on one side. So subtract 2x from both sides, and all of our constant terms on the other. We're going to add 16 on both sides. All right. That way those will cancel and those will cancel. So you wind up with 2x equals 19. Wow, we have the same problem as before. All right, let's divide both sides by 2, and we get x equals 19 over 2. All right. Now we would need to plug this value in for x in the original equation and on the right side of the original to see if we get the same value back. All right. Let's try that out. You could use your calculator for this, but we'll go ahead and do it by hand. 4 and then the square root. We've got 19 over 2. Actually, no, I am not about to do this by hand. All right, that's not going to work out because I can't do the square root of 19 over 2. Can I? Square root of 19 over 2? I don't think that's going to play nice, but we'll just use the calculator just as a fallback here. All right, so we have 4 square root 19. Let's actually put that in parentheses. 19 over 2 minus 4. All right, that is the left side. That gives us 9.38. Yeah, it was not going to come out nice. So on the left side, we get 9.38. 9.38. All right. And on the right side, we have 2 square root 2, and then we're plugging in our answer here, 19 over 2, plus 3. Bam, we got the same answer. All right, the right side also gave us 9.38. So that means that 19 over 2 is a valid solution. It's a good solution for this equation. All right. Let's take a look at our last example here. All right, here they're already isolated. They're already by ourselves. Let's just square both sides. And we're going to get 4x plus 1 equals 3x minus 4. Subtract 3x from both sides. And then we'll subtract 1 from both sides. And we'll get x equals negative 4 minus 1, negative 5. All right, now this one's actually very easy to check. Plug negative 5 in just to the left side. 4 times negative 5 plus 1. This is going to give us negative 20 plus 1, which is negative 19, which is an imaginary solution. All right. Now, it's also going to give us the same thing on this one, but because we end up with imaginary or non-real numbers for solutions, this means that x equals negative 5 is not a valid solution. That is called an extraneous solution. All right. So it's the solution we get by following the rules, but it does not satisfy the original equation.